Here we have an exponential function that represents the population of a city in thousands, and the input variable x is time in years since 2000. And we have about 4 questions to answer. I'm actually going to start by answering this one because it'll help me explain the first question asked here. So what was the population of the city in the year 2000? So our input variable x was in years, and then if you look at it since 2000. So if I wanted to predict what happened in the year 2000, say, the year 2000, you would not use an input of 2000 because my input is in units of years since 2000. So I would argue that the year 2000 is 0 years since 2000. So I would plug that into my equation. Here's my equation, f of x equals, and we are letting x be 0 to represent the year 2000. So if you put 0 in for the input variable here, you have to put it up here as well. So what you would get out of that is that numbers to the 0 power, with only one exception, is 1. And then you'd have 300 times 1, or 300. And remember, my output variable, f of x, is the population, but it's in thousands of people. So you have a choice. You could answer the question, what is the population, either as 300, and you could write 1,000 people. Or if you don't like writing it that way, you could write it as the number 300,000 and then say people. Now back to the prior question here, is the population growing or declining, and at what percent rate? So imagine plugging in, say, x equals 1 to predict what happened in the year 2001. And that'll help me explain what the percentage increase is. Or is it growing or declining? The answer is that it's growing. And to explain what the rate is, you need only take and plug 1 in to figure out what the percent change is from year 0 to year 1. So if you replaced x with 1, and remember, really should have written the equation down here just to be a little cleaner. So in the first explanation, I replaced x with 0. Now I'm replacing x with 1. And so basically it says the population is going to be whatever 300 times 1.15 is. So let me off to the side kind of talk about that just for a second. 300 times 1.15 can be thought of as 300 times 1 plus 0.15. So if you were to distribute this, what you'd see is that you'd get 300 times 1 is 300, which is my population in the year 2000. I like to think of that as my original. This was my original population in the year 2000, but in addition to that, we're going to get some change, and the amount of change you get is going to be what you get when you finish the distributive property here and multiply the 300 by the 0.15. So hopefully you recognize that 0.15 is the decimal equivalent to 15%. In mathematics, multiplication means of. So 15% of 300 means 15% times 300. So I need not even know what that number is. I just need to justify that the number is going to get bigger, and by what percent is it going to get bigger? It's going to get 15% bigger. The 1 here is to keep the original amount, or you can think of it as the amount from the previous year, and the 0.15 adds on 15% of the previous year. And that pattern would continue. Every time you multiply by 1.15, it's going to increase by 15%. And it's growing at a rate of 15%. That wouldn't be enough. If someone told me something was growing 15%, I would say, how long does that take? Per second? So you really should say per year. This question, the idea would be that if I wanted to predict the population in 2018, remember that my input variable is years since 2000. So 2018 would be 18 years since 2000. So I would be plugging in 18 for x, and I'm going to need a calculator on this one. So plugging x equals 18 in here and there. And I'm just going to round to the nearest thousandths, I guess. Let me go to my home screen and type in. You know, while I'm at it, I might as well show you that had you raised to the 0 power, remember I just did that calculation for you, but had you raised to the 0 power, I get 300, as I stated before. If interested, you could do the same thing and raise to the first power. By the way, if you were to press second enter, it retypes the last thing you did, and I can just back arrow over and change that to whatever I want. I'm going to cut to the chase down here where I was to predict the population in the year 2018. I get 3,712, and then if you want 0.636, because this digit here is a 0, I won't round this up. So I'm going to use 3 decimal places and show you why in a second. So I get the population to be 3712.636, and that's in thousands of people. So you either say that the population is 3,712, and if you want, you could add on 0.636, and you might say, wait a minute, you can't have 0.6 people. And I'm going to say, wait, but that isn't 0.6 people. My units are in thousands of people. It said it right here. So you can have 0.6 thousand people. In fact, you can have 0.636 thousand people. So what you may want to do is you can write it this way, or you can move the decimal to the right 3 times. The fact that the number 1000 has 3 zeros means to convert something from thousands, I forgot to write thousand here, to convert from thousands of people to just people, you could move the decimal over 3 times, and then that number would be 3712. And then if I move the decimal over 3 times, because I rounded to 3 decimals on purpose, you would get 636. And going backwards and putting the commas in, another way of saying that your population is 3,700,000 people would be to say there's 3,712,636 people. So there's my answer to that one. The last one I haven't done is in what year? And remember, X is in years. So we don't know X. We're actually asking for X. Find X. In what year will the population reach 600,000? This is where you have to be careful, thinking that since the output variable is the population, that you would want to take this and replace it with 600,000. But what you have to remember is if you put the number 600,000 in as an output, it's already in thousands of people. So you wouldn't be finding when the population is 600,000, you'd be finding when it's 600,000, which is 600 million. Not what the question asked. So what I'm going to do is not make that mistake, and I'm just simply going to put an output of 600 there. If you put 600 in for f of x, because the output is already in thousands of people, 600 does represent 600,000. So when I solve this equation, I'm going to just replace my output variable with 600, and I'm going to solve this a couple different ways. I'm going to solve it first by hand because it's pretty simple, and then I'm going to show you how to use the intersect feature on your calculator. So first thing I'm going to do is, since the 300 is being multiplied, I'm going to divide both sides by 300. On the left, I'd get 600 divided by 300 is nothing more than 2. And over here, 300 divided by 300 is 1. So to solve this, there's many different methods. One method by hand would be to change from exponential form to what's called log form. To change to log form, you take the side of the equation that has the base and the exponent. The base is 1.15. That always goes as a subscript to the logarithm. And the exponent always goes over here. So since 1.15 is being raised to the x, I will put x here. And that would look like this. So it's 1.15 to the x is to give me that result right there. So we know that 1.15 to the x is supposed to come out to be 2. Now it would be a matter of just taking my graphing calculator, which doesn't do base 1.15, but I could on my graphing calculator do the log of 2 and divided by the log of 1.15. This is called the change of base formula. And if you want to know why it's called that, it's because this was a base 1.15 problem, but I've changed it to a base 10. Now on your calculator, it won't show the base. When you type the log key there, it doesn't put the base there. You are to assume, since we're not writing the base, that we're talking about a base 10 logarithm. So you would type log base 2, and you would divide by the log of 1.15. And remember, this is time in years, so we don't have to get too technical how many decimal places. It's about 5 years. If you want, it's 4.96 years, 4.96 years. Remember, it started at 300,000. It takes 5 years to double all the way to 600,000. Now, I promised that I would also show you on the calculator how to solve this using the intersect feature. The original equation was just this, and to solve this equation on your calculator, what you do is you type one side into y1, the other into y2. So one of my equations is going to be 600 to represent the population of 600,000. I'm going to go down, and when I go down, type the other side of the equation, which was 300, and then in parentheses 1.15, and then right parenthesis, use this caret key here to exponentiate to the x power. Here's the x key. Now there's no need for me to graph this in the standard window because I know that I have something that starts at 300 every year it grows 15%, and we want to know at that growth rate of 15% per year, how long will it take X in years to grow from 300,000 to 600,000. So if you go to your window, it doesn't go as high as 600. If you're in a standard window like mine is in, you're only going to see as high as 10,000 people. So I'm going to change this to say 700. So I will see as high as populations of 700, but remember it's in thousands. So when I graph it, there's the horizontal line 700, representing a population of 700,000. Here is my population. If I had axes here, you'd notice this is 300, and then it's growing 15% per year, and it's going to intersect at about 5. You can even count the tick marks down here. 1, 2, 3, 4, 5. Somewhere around x equals 5, if you go straight up, you'll see that they intersect there. But if you want more accuracy, press second trace to access the calc menu. Since the intersect feature is number 5, I will press 5, and then it'll ask, is this one of your curves? Is this the first curve you typed in? Yes. Press enter, and it'll pop to the second curve and say, is that the second one? You press enter, and then to guess, you can, if you want, scroll over to the right and get closer. The guessing feature is mainly if you've got more than one intersection and you have to tell the calculator which one you want. So there again, I get it, that the intersection is about 4.96, or roughly 5 years.